when we drew the straight line, coming as close as possible in the average to these points, and we really didn't do all that good of a job. The line should have been angled up a little bit more, I think. We didn't attempt to actually go through any of the points. We weren't looking at going through points. We were looking at minimizing our total distance between the line and the points. Actually, what we do is minimize the total of the squared vertical distance, but for now we just think of minimizing the distance between the line and the points, and we'll get more specific on how we do linear regression later. Now, having obtained the line, we take 2 points in the line, a big green point down here and a big green point up here. We don't take data points. The data points all have errors in them. We assume that the line does a pretty good job of modeling what really happened rather than little errors in our reading of the data. We take the coordinates of 2 points in that line, and we're going to use those coordinates to find the y equals mx plus b equation whose graph this line is. So we estimate the coordinates of the point. Our estimate was this point was 0, 38. It's actually a little bit this side of 0. I'd say maybe 0.4, 37.6 or something. But we'll just call it 0, 38 because those are nice whole numbers and easy to work with, and we're just trying to illustrate the process. When you take the actual data and do your own plot and do your own straight line, you're going to be more precise than this. You're going to estimate things very precisely. Okay, and we take this point and we estimated that this was, if this is 15 cups and this is a 3-cup difference, then 18 would be here and this might be 19. And that the height of the graph here seems to be about here. If this is 60 and this is 50, then this might be 68. These were estimates by people in the class, and they're good estimates. They're perfectly valid estimates. Now, if we assume that this point and this point lie on this straight line, how can we find the equation of the line? There are a lot of ways to do that, but we're going to follow essentially the sort of thing that we did when we obtained a quadratic model. Okay. Our linear model, we know that the equation is y equals mx plus b. From our study of the basic function families, we know that this is the general form of a linear equation. Now, the point 0, 38 means that x is 0 and y is 38, if we let x be the number of cups and y be the spring reading. Then we put in 0 for x and 38 for y. We get this equation, 38 equals 0m plus b. We put in 1968. I started to put that in backwards. I'm real bad about doing that, and I've always got to check myself. Cross that out and put it in correctly. 68 for y, 19 for x. What do we have? We have 2 simultaneous equations in m and b. This is much easier than what we had when we did a quadratic model where we had 3 simultaneous equations. These equations are particularly easy because I used an x equals 0, so I immediately see that b is 38. I could plug that in here and solve very easily for m. It's going to be 30 over 19. So we see that it's very easy to find a linear model once we have 2 points on our linear graph that fits our data.